Starting the stream is better than crossing the streams. Hey, that joke still worked. All right. We are now going to work on the R section of the class. So I'm going to, if you haven't already done this, please go to my webpage for class. And if you haven't downloaded R or RStudio, please do so. Typically, I install R first, RStudio second. I don't think it actually matters, but you need them both to make this work. The R package itself, when you go to download it, you go to some place where the download site is this CRAN, Comprehensive R Archive Network. And sure enough, the R here is fresh. We have a mirror here on campus. So, yeah, you'd probably like to see this, right? So yes, class webpage, download R, our website, CRAN, Comprehensive R Archive Network, and we have a mirror here on campus. Isn't that cool? Like of all these places in the United States, we're with the Berkeleys and the Iowa States. Maybe not. Never mind. Anybody like Iowa State? Anybody? Should we nominate them for? Oh, no, maybe. I saw a head turn. Maybe. No. Okay. So just trying to think of which school should we pick on the most. You know, Iowa State's a strong candidate. No, actually, I do like Iowa State because they have a great stat program there historically, and some of the stuff we're going to get into in class. One of the big players in that field is from there. It worked there for his career, so I'm really pretty cool about Iowa State. So I shouldn't say that. Anyway, we have a CRAN mirror here, and you can download R. I like that R pretty much works the same on any of these systems, which is great. For RStudio, it's a little bit more complicated. I swore I'd never use R until I had a great front end to work, so you can download RStudio. When you get here, it's like, oh my goodness, what am I going to do? Take the RStudio desktop, and that will be where the platform happens to be. You pick your favorite one, Windows, Mac. Anybody use Linux in here? You're better off without it. I shouldn't say that. So you can get RStudio as well. So when you download both of them, RStudio is sort of the shell, and R is the part that it gives you access to. So here, let me just quit that real quick. Start RStudio, and of course, when I switch my screen resolution, can you see that okay? Is that a good font size? Here, when you start it up, again, you get this blank screen. So let me walk you through a little bit of what you work with here. The console is on the left. This is what R looks like if you were to start R in its native environment. Whoa, right? So you type commands at a console, and it does stuff. It's very much like the command prompt in your old computer days, right? Maybe that, I don't know. Never mind. Maybe you're not there. My old computer days. The stuff on the left, the stuff on the right is going to be increasingly important. The top part is called the environment. That is what R has to work with. Right now, it's empty. There's nothing to work with. But when you put your data in, it'll show up there. When you do an analysis, it shows up there. The environment you can think of as like your folder of stuff. It's just all housed in the memory of the computer. It's not actually written to your hard disk or to your whatever disk that you have. It's actually stored in physical memory on the computer itself. So R is a notorious memory hog. So if you copy something, it expands. It takes more sections of your RAM on your disk itself. The history and the connections happens to be there as well. I don't do much with connections and history in this. History is what you've done for commands. On the right-hand side, you'll see a bunch of parts. The first part, the files, is nice. It tells you the directory that you're in, which is helpful particularly when you're dealing with trying to find where your data are, right? Because that's like the first thing you want to do with R. Get your data into it, right? Okay. Because I started RStudio from just as an instance from the application itself. I didn't start it by opening one of the scripts for R files. It defaults to putting me into, in my case, the root directory of my computer, just right there. We'll talk about that later. Once you make plots, they'll show up here. If you have packages installed, which I'll talk about shortly, you can see which ones are there. I really wish they'd put quotes around help. It's like, help, right? Or maybe like, ha, 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 like a laugh, right? Something like that, because it's written either in R speak, like this weird language of all the stuff, all the nouns that R uses to do, or it is actually, there's some help files that are really helpful, but really what happens is the documentation gets written usually by the package author. And so on top of making sure the package runs and does all that stuff, then they have to document it, and the combination is lethal. But no, I think it's tough. I'm hoping to avoid you having to go there, because I remember when I was using R at first, how many hours I spent trying to, what is this in R and why is it not working and whatever else. So I don't want you to get in that spot. Finally, a viewer. The viewer there's some great things RStudio brings in that we won't actually be able to get to in class. One of that is you can actually create papers in RStudio. Like you can write things in a language called Markdown. You can push a button and all of a sudden it'll compile it into a nice paper that could be online. Or if you add a certain package, it'll make it into an APA formatted paper that you could submit to a journal. It's pretty cool. So all of that gets built in. And one way, the viewer is a way that you can see HTML or anything. By the way, if you have questions through any of this, please raise your hand. Please stop me. It's intimidating looking up at you. So I'm sort of trying to fight the urge to stay down here. But please do ask. Please raise your hand. Please, please do get my attention. I want to answer your questions. So now that I've shown you RStudio a little bit, I'm going to close it because what I'd like to do for most of class is whenever you have an R file, to just open that R file directly, because that'll put you into the right folder for RStudio. So I'm going to go back to the course web page. I'm going to go to our first class and find our R working example zip folder. Find my folder, open it up, and in that folder, I have a file named Make Friends with R. Borrow that from Lisa. Lisa has Make Friends with SAS, Make Friends with Stata, Make Friends with SPSS. She does not like R. She is a hate R as well. But that's the file. And I also have a couple data sets in here. I am going to now open up the file by double-clicking it. It should work. Windows may not do this. If you've got a Mac, you can open the file. And now if you look at the files spot on the right-hand side, I'm no longer in the root directory of my computer. I'm actually in that folder itself. And that's helpful because now, whenever I want to load in one of those data files, I just put the name of it. I don't have to put the whole path to it. It goes up short. Yes, Ron. Pardon me. You're on a Windows machine? I tried double-clicking. I don't know if it will double-click on Windows. Does RStudio pop up? Oh, I'm sorry. Oh, pardon me. Let's scroll here. Right there. And then scroll on down. That one right there. There you go. And actually, this is great. I've never taught a class with a TA in this class version before, so Jihong, I'm going to work with, if we have a question like that, Jihong will assist you. Come to your computer. He's like, what's the Best Buy tech support people? What are they called? The Geek Squad. No, he's not the Geek. That's a negative name. No, you're better than the Geek Squad. So anyway, personalized help. Everybody else, did you get that file open? On Windows, were you able to double-click to open up RStudio? Yes. Fantastic, because I remember that used to be an issue in RStudio. We couldn't double-click. It didn't default to making it the default file type to open with. So when you see RStudio and you've opened the file, do you see in the bottom right-hand corner for files the folder that you're in? If you don't, Jihong, would you be able to?
I already got it open. It just doesn't
Okay, I'll show you how to fix it when we get there. Okay. Yes, question. Aisha.
How do I close data sets that I have open from over the summer in the environment?
In the environment. If you want to get rid of them, if you hit this little broom button, that will clear everything from, and hit yes. It will clear it all away. There you go. Yeah, if you save, so here's the funny thing that RStudio does by default. If you save, if you're working in a directory and you exit RStudio, it'll usually ask you, do you want to save the environment? So basically, do you want to save the contents of what you see, what R has in memory, to your disk somewhere? And if you click yes, it doesn't save it with an environment name. It makes it a default kind of hidden file. So that means when you open up R again, it will always be there, even if you don't want it to be there. So I typically do not say yes to that. If you get to closing RStudio and it says, do you want to save the contents of your environment, I usually tell it no, but I'll show you that in just a moment. Other questions? Okay. So I'm basing this off of this little example off of what Lisa did. Is this a big enough size, or would you like it larger? Anybody larger? Okay, I'll keep it here. So in R, the nice thing about RStudio is it helps colorize a little bit of your code. Anything that you see in green that starts with a pound or hash sign is a comment. So what a comment means is if I were to highlight a bunch of the syntax and hit the run button, it would do nothing. It's skipped. The R system is not reading it, not evaluating it, not doing work with it. A comment just means, yeah, don't pay attention to what's behind here. Once you put a pound symbol into text, everything to the right of it is a comment. So everything that goes on to the right is a comment, including if you make it a new line. I won't get to that yet. The other thing about it is comments, there's no multi-line comments. If you're used to other syntax languages like Sass, or if you're in a programming language like C or C++ or even HTML, you can make a big block comment. You can't do that in R. You have to comment each line. Now, here's where RStudio helps. If you highlight a block of syntax, and under the code window, there's a comment uncomment lines feature. If you hit Command Shift C on the Mac, it may be different on Windows. You see what it just did? Shift Control C with a block of syntax. It will take the comment off for you. If you want to put the comment on, highlight that syntax, hit the same Shift or Command, Shift Command C or Shift Control C, and boom, it becomes a comment again. So that's one of the nice things RStudio does. It does save you time in trying to write syntax.
Why do you want to comment?
Oh, sorry, whose question is it? Oh, pardon me.
Why do you want to turn it on and off?
There may be times in your code you don't want to run a section of it. You might want to say, well, I already know how this works. I'm just going to block it off and not look at it. And that'd be one of the reasons. But in general, if you can't think of anything, don't worry about it. You haven't come to it yet. But you may come to a time where it might work. I'm sorry I didn't see your question before. And that was Sammy, right? Yes, thank you. Other questions?
I didn't say a question.
Oh, excellent. Excellent. Thank you. So green is comment. The other time you've seen green is if you create a character string, but we'll get to that in just a little bit. The other nice thing about RStudio is you can use the tab key to complete parts of the syntax. So you can sort of take a guess at what the syntax should be, and RStudio will help you fill it in. For instance, one of the first commands we want to use is print. I'm going to type it first. It's actually written below. If I type print, it starts to suggest things. And you notice I didn't spell it right. Of course, I have a typo, because that's me. Print. But you see it's highlighted below. If I hit the tab key, it completes it, and it creates the section where I can put things involved. And furthermore, if I hit the tab key again, we're going to learn about this in just a moment, but each of these, R works through a series of functions, and the functions have these parentheses. The stuff that goes in the parentheses has to be named, or you have to know the order of it, so you can figure out what it happens to be. Oops, I can't even type. And so here is where I can type print x equals hello, and it will complete it for me. So the nice thing about RStudio is when in doubt, just take a guess and see what pops up. And what will pop up usually is something to help. Ahmed, is that about right? So it's how I use it, at least. By the way, I'd like to think of myself as an advanced R user, but the more I use it, the more I realize I don't know that much. So if you have tips or comments that I'm not talking about that could help the class, please share them, and we'll make that work. Okay. Yes, Jacinta.
So you know, in Stata you can use a control D to make it go.
Yes.
Is it
Control Enter
Control Enter
will make one line of syntax run.
Yeah. Thank you.
Yep. Yeah. So if you wanted to make a syntax run, but you don't want to hit that run button up there, Control Enter makes it submit. So, other questions? How many of you hate R increasingly? I'm right there with you. I'm right there with you. Let me tell you, but I promise you, this is good for all of us. I promise. There's a payoff to it, right? If you can do R, I feel like you've got a better future ahead of you. All right. Yeah. We don't need a lot of mechanics for 67 Chevys anymore, right? That's sort of where we're looking at here. It is, absolutely. So is SPSS. Sorry, I don't mean to knock SPSS. I used to love it. When I first started in grad school and I had to use SAS, I'm like, dude, where's my data? I can't even, it's just this little command console thing. Anyway. Okay. The other part about R that can be frustrating if you come from other languages is that it is case sensitive, meaning a capital R and a lowercase r are two different things altogether. And for instance, and I'm going to go type this down in the console now. So I just highlighted the console. Anything you don't have to type your syntax in the syntax area. You can type it directly into the console below you at the command prompt. The difference is in the syntax area above, it saves what you've typed because it's a text file. And if anything you type into the console below gets lost, well, it goes part of R history, but it's not copy and pastable directly as easy. But if I were to go and type the print command again, so if I type the word print, and I hit tab, and you see there it is, and I put in, and I say x equals, and I put in quotes, hello, and I hit enter, R reads that and says, okay, I need to print the word hello to the screen. Boom, and it prints it, right? But R being case sensitive means the following. If I change print, if I had the caps lock on and I typed it in as capital print, it now has an error, right? So that means the case of the letters matters. And one of the frustrating things about R is these functions, the things that we're running, the commands that we're running, tend to get developed by authors that are not part of a common cohesive style. So you have to understand what the commands are to make it work, and that's where that tab function helps a lot, right? When I start typing the word print, I can go and tab down and see, oh, it's in all lowercase, right? Even if I were to start typing it in uppercase or capital letters, it still suggests a lowercase version of it. So that's where RStudio really helps. If you were just in the single R editor, I wouldn't be teaching in R if it weren't for RStudio. Let's just put it that way. Wouldn't be wasting our time. Other questions, comments? How are we doing? Is this a good pace? Cool. So R is what is called a functional language, which I don't fully appreciate what that means. But it basically, to me, my own impression of that, my qualitative feeling about what that means, is that everything works through a use of what's called a function. A function is a set of code that you call with a command. So print is one of those, right? An underlying print is the word function. That doesn't help. Basically, when you say print and you tell it what to print, R goes off and executes a series of other commands that you don't have to type that automates it for you. Right? If you are familiar with Visual Basic for applications, if you ever hit Alt F11 in Word and popped up a syntax file, that's a macro file. Functions are like macros. They're not exactly like macros because a function will take input values and do something and then send things out, whereas macro values don't necessarily need inputs and don't necessarily have outputs, but basically the same. So the print function is the very simple function. It prints whatever you have after the X to the console, like that. So here this is the number 10. It prints the number 10. If you want to figure out what terms go in the parentheses, you hit question print. The question mark will pull up the help value for you in the bottom right part of RStudio. You can also search, by the way, for help over here. The search is just as effective as the help sometimes, although it's gotten much better. It used to be way worse. So print, the description for help says it prints its argument and returns it invisibly. It is a generic function that means new printing methods can be easily added for new classes. So this is the REs that I was talking about, the R language. If you're really into R, you'll get what that means. If you don't worry about it. Basically, print prints whatever you tell it to the screen. Now, why would you want it to print? You probably aren't going to encounter that in class. Where I use print the most is within a loop that does repetitive action. If I want to see what it's doing in the middle of it automatically, I just stick it in a print function and it prints it out for me. But we probably won't have many of those in this class. Yes, Ron?
So if you type something in console, does it populate it above?
It does not. No, it only typing to the console is like your quick access to to see how it runs. Whereas if you want to like actually do it in syntax, I rarely ever type anything in the console, to be honest with you. I did that here just to kind of show the different points. So print. Each print function will return an object. So each function itself. So let's go through what a function is. A function is a command, so a keyword, followed by a set of parentheses. And the stuff that goes in the parentheses are called the arguments to the function. So you can already tell this is combative language. There's arguments involved. Maybe that's not right. I don't have any legal people here. Would that be, I don't know. Anyway, we have arguments. I'm trying to make it less dry. Any other type of bad R humor, let's go for it, right? Like let's be honest. I'm totally in dad mode, so like any terrible humor is just going to happen, right? It used to be I was just a geek or a dork or whatever else. Now I'm just dad, so all right, I embrace it. The arguments of the function show up within the parentheses. The way that I like to put my syntax is to put the name of the argument there, so x equals. And the reason for that is you can actually write syntax without the name of the argument there. But it gets very hard to run, or really hard for other people to understand it, without telling them what each thing that you're giving to the function is doing. And the argument helps set the context. So I'm not even going to show you that other method. We're just going to keep it like this. So print returns it. When you print something, it prints the screen, and it says it returns an object. So what do I mean by return? Well, I could save what print is doing. And in fact, I'm going to, actually down here on line 37, I'm going to create a variable name called myObject. The type of, by the way, the way I tend to do my R style is something called capital case or camel case, where I have capitalized letters, capitalize the first letter of words that go together. Remember, it's important because R is case sensitive. So if I type this command right here, myObject equals print. If I go to run or I hit Command Enter, it submits it to the console, and you'll see over in my environment, I now have an object. A global environment this thing is called myObject. Right? It's a variable. It's the term I use for it is object. It's just this entity that is the result of the function. which is weird because the function really all we're using it for is to print a screen, but it also sends back what it printed. So that's what shows up over here. And if you want to know what type of the object that happens to be, there is a function called class. So you put class, and in the parentheses you put my object. Now you'll note this is not a named argument. I could probably put x equals. And it will tell me that object is numeric. So that is it's a number. So R as a default, objects, and I'm getting into R now, right? Yeah, numeric. Sorry, is anyone ever get that excited about no? No, I'm getting up because I want to share a story. Yet another dad characteristic, you know. The deal is the biggest thing that screwed me up in R, looking back on it, were the differences in the types of objects that exist there. If you're used to SAS or SPSS, there's data sets, right? Data, right? And you go and you have a drop-down menu in SPSS and you say, do this, and you usually only have one data set up at a time, so you don't have to choose between data sets. Now, if you're in SAS, they might have a library and there might be a handful of data sets in there, but they're all pretty much the same way. And until you get into the macro language, or the under the weeds of SPSS or SAS, you don't have what are called macro variables. If you're familiar with those, that's what objects are in R. They can be anything. They can be a data set. They could be a string of character of text. They could be a number of numeric values. But the default version for them is something called what's called an atomic vector. It's just a set of these same type of objects put together. And our my object that's up there right now is a vector of length 1, right? And it has the number 10 in its first spot. That's it. So we're going to, one of the problems that we often encounter when we're getting to learn R is that you'll have a type of object that you think is data, but it's not. And you submit it to a function that wants it to be data, and the function complains or it drops an error. It says, hey, don't do that. And of course, the error message is really cryptic. I mean, if you were 15 years into using R like I am, oh yeah, I get that. Maybe. But at first, it's pretty hard. But what I've introduced this to you because one of the things to look at for each object that you have is to just ask what class is it? What is it doing? What is that type of object itself? All right, so for instance, I printed 10 to the screen. What if I put 10 in quotes? All right, so now the number 10 is now a string, 1 and 0, characters. The class of that is no longer a numeric, it's now character. All right, switched it over for me. So, if you want to see what the contents of the objects are, you can type the name itself and it shows up in the screen below us in the console. Or for data frames, for some of the values over in the environment, you can double click them and it'll pop up the data set itself. Pardon me? Not ours right now, but coming up. For a data set, we can double click it and it will view it for us like a grid that's over by the syntax. I'll show you that in about 5 minutes, I think. With the way I'm going, probably like 10. But, well, it'll be coming. So. Other questions? Okay. So, R has a function. The typical process in R is we call a function, we give it some arguments, and it returns an object. And that process of calling an object a name is something called assignment. We're going to assign the numeric value 10 to the name my object. That's what's happening in R underneath the hood. And of course, R makes it so that assignment you can use different characters to assign names to objects. And why I'm mentioning this is because I prefer the equal sign. I like saying my object equals what's on the right-hand side. Right? This is a right to left assignment. Right? Whatever's on the right-hand side, whatever the print function returns, gets called the name on the left-hand side of the equals. However, you may see people in R use this arrow-looking thing, right? The whatever symbol that is that less than symbol? less than dash, is that right? Which also does the same thing that equals does. It assigns the thing on the right to the thing on the left. So now if I create a new one called myObject2, right, myObject2 has the number 10 in it. And there's an identical function. It says, is the object you put in the first part identical to the object in the second? And it tells you true or false. The answer is true. It's like the magic 8-ball of one of the world's worst magic 8-balls. Yes, they're the same, right? So why I mention that is because if you look at other people's syntax, you may see this arrow everywhere you go. I hate it. That was the other big impediment for me in R. I hate it because it's multiple buttons I have to push, and it's the thing I tend to do always in R. There's always an equal sign. I always want to assign objects to names. In RStudio, you can hit the Alt button and the dash, and it will make an arrow-looking thing for you. But understanding a little bit, I believe, my R history, I don't have great R history, but I want to say I read somewhere at some time that R is sort of one of the predecessors to R was a language named Lisp. And Lisp was built on an operating system where there was a keyboard that had an arrow key built in, so it was one button push. But no, now we have everybody using arrows, and it drives me nuts. I don't know why it drives me nuts that bad. I hate hitting multiple things for the most important character on the keyboard is equals, and I have to hit multiple buttons for it. It drives me nuts. So, now that being said, if you change the direction of the arrow to a dash and a greater than symbol, this provides assignment from left to right. Right? So if I do myObject3, if I hit enter on this command, it takes the thing on the left and puts it into the thing on the right. So there is, if you want to go and if you really want to like enjoy a great funny discussion that you want to stay out of, if you got two people who love R in the same room, say to them, I use an equal sign for assignment, and watch their heads just explode. It's like you just are violating all the principles of the language itself. But I'm violating them because I hate pushing more than one button. It takes more time and I hate it. But yes, they're all the same. So, long story short, R works with functions. Functions take arguments, and they return objects. And the way that we capture the object is to name it something, to assign it to a name, and I typically do that with an equal sign. So far, so good? When we capture the object, it shows up in the environment up over in the top right. And that helps us know what we're working with.
I just
Yes.
one thing.
Yeah.
There is the command that allow R to know this is the object. That's what I have right here. Which line?
So if I want to say my object, this one right here, this line right here says, whatever comes back from print, assign the name my object to. So that's that right there. Is that what you're mentioning? But each of these lines, this line 53, line 56, and line 61 are all identical in that regard. They look different from syntax, but they give the same result. There's more than one way to do the assignment in
I
R.
don't have to use the word my object. I can use it.
You can use anything. Yeah, you can call it, I hate R. Right? I think actually, my early days of R, I would do that spitefully. I would name every object something terrible, like dumb object 1, or I don't know. Okay. So part of the reason though, so now we're sort of getting into this. It's less the drop-down menu thing that you're used to if you're used to SPSS, particularly the graphical interface. But where the power of R comes into is the use of something called packages. R packages allows you to download basically add-ons to R. They're like miniature applications that extend what it can do. And contained in an R package is a series of either functions or data libraries or both, and sometimes a series of example analyses called vignettes that tell you how to use the package and the statistics that you're doing. The great thing about packages is they are typically developed by those who are developing the statistics. And so if you're a person in the stat field or in psychometrics these days, pretty much you're always creating an R package for every new thing you're doing. And that means you don't have to wait for SPSS to create it for you. You can go and probably take this brand new method that you've seen, or maybe new to you method, and find a place that someone's done it before and use their syntax for it. So it makes the accessibility of some really modern and new stuff possible. And that's why R, to me, is sort of forward-facing. You know, for SAS has done great things. If I weren't to pick R, I'd probably pick SAS as a language I'd go with. And it's starting to get to a place where users can submit packages and they can certainly do macros and so forth, but it's nowhere near as easy as R to use for this. So we're going to install a package. To install a package, there's a function called install.packages. This technically installs a package from that CRAN's Comprehensive R Archive Network that we saw before, where we downloaded R from. That network has packages that have been vetted to make sure they work on each system that you might have R in. They're not vetted to make sure that the code works great. There may be bugs in the code, but it at least will compile or run or install on your Windows machine or your Mac or your Linux, or they even use, oh my goodness, I'm blanking on it now. There's another, I've lost it again. Anyway, another crazy system. So what we're going to install as an example is the dev tool package. Dev tools. What dev tools is a series of functions that will make it easier to download other packages, namely the one I created for this class. So we have an R package that I created for this class, but I didn't go put it on the CRAN network because it takes a while and I'd probably screw that up too. I put it somewhere else, you'll see in a few lines. But dev tools will give us the function to do this. So what do? We just hit run this command right here, install.packages, and you'll see if you're connected to the internet, it's doing stuff. It downloaded the package directly from CRAN, and it installed it. And this is the place where you may get some errors. Sometimes installations don't work well, and if you do get errors, let me or Jihong know, and we'll definitely get to you. But what installing the package does is it goes out and it grabs the files for the package off of the internet, downloads them, and unzips them or installs them on your computer somewhere. What it doesn't do is it doesn't load them. So, yeah. This line right here, I have it on line 79, although I may have deleted one by accident. Install.packages, if you hit the run button on that with the cursor on that line, it'll submit the word run.packages to the console, and it will go through the following. It will download the package from CRAN, or it should, and then it will install it, and sometimes the installation may take a while. Does that? Yes? No, it does not matter which line. It can be anywhere in the text file. I'm just, yeah, that's right. So DevTools is a package we've downloaded, but to use the functions of the package every time. So now we only need to run DevTools install.packages once on our computer. Once it's downloaded off of the internet and it's on our local machine, it will run always. We can use it again, but we don't have to. But to tell R we want to use the functions in the package, we have to go and tell it library DevTools. So this library function loads all of the functions that are embedded in DevTools to work. So in our class, and we're about to take a break again, so I'll get back to this when we come back. But just briefly, our class, we have a number of libraries that we're going to use. So this installing and then loading is a process you're going to be very familiar with as we go on. All right, let's take another 10 minutes and come back about at 3:30, a little thereafter. Yes?
So if we have an old version of R, like 3.4.1,
Yeah.
how do you update it?
To update R, you just re-download it and reinstall it. And you may have to, depending on the system you're running, you may have to delete it, the old version. But re-download and reinstall is pretty much the only thing. Thank you. All right.
without altering